Hi, everybody. So, I've recently been watching some debates, quote unquote debates, between some creationists and what is bizarrely being termed either atheistic evolutionists or atheists or things of that nature. And the reason I say bizarre is because for many of the creationists, if you accept evolution as valid science, they automatically label you as an atheist, or if you claim to have religious leanings. I haven't heard them outright call anybody an apostate, but they very well might. I don't want to project, so take that statement with a grain of salt. But um, the reason I am making this video, and some may say, why give life to the debate? And I understand that sentiment. Why even draw attention to this issue? Um, but also at the same time, it's necessary to combat information that is given in bad faith with information that is given in good faith, and that is what I'm attempting to do. And we have a very serious issue in this country with science education, basic science education, and we are um, hurting in our society as a result of this misconception, or a series of misconceptions about basic science and what science is and how science works. And that is what I'm attempting to address with this video, and probably a few others that will shortly be forthcoming. Um, and so, what I want to do is start by looking at a debate that was done by probably the second most famous creation science evangelist, Kent Hovind. And this particular debate was done in April of 2004, right? At Embry Riddle University. And he debated three professors, science professors. Um, and the professors held down, in my opinion, held down the science very well. I wish they would have approached the entire debate a little bit differently. As a prefix or preface to the video that we'll watch here, Hovind is very eloquent. He's very well rehearsed, very polished. And so it's very easy to catch people off guard and not give them time to think in a live debate. And it's easy for me to sit back, take several days to process my thoughts and say what I'm about to say. But would I have been able to do it live in the moment under the stress of the moment? Who knows? I'm a decently fast thinker in situations like this, but I wish I were better in many cases, as probably most everybody does. But on reflection and looking back and processing this, um, there's a lot of things that one could say. So I'll try to make this video brief. I will try to make this video somewhat short, hopefully under an hour. We'll see. It'll be what it is. But before we start, okay, before we start, let's get one definition out of the way. And that is, what is science? Okay, so Kent is going to throw this word around a lot. Um, and we have to understand what science is, what its purpose is, and what its limitations are, right? Science is a field within the human endeavor, and there's many subdisciplines, but it's not the only field that informs who we are as a people, as a society, as we live together, as we try to coexist. It's not the only tool or mechanism that we use to figure out who we are as people. And religion certainly has a role to play in this. And just for background, I myself am a Christian. I was raised in a Christian home. I would consider the last few years of my life, probably the last decade to 15 years, what the modern term is for deconstruction, where I've thought long and hard about my upbringing, my faith, and things that I've been trying to process through, and how to make things make sense, right? And that's what a lot of people who've been doing deconstructing are doing. And I would put myself in that category, but that doesn't mean that I have rejected all of Christianity in any way, shape, or form. But that being said, so let's define what science is and where its limitations are, and then we'll jump into the video and we'll talk about how a lot of Kent's statements don't match up with the topic of the debate that he was in. And this is why I wish the professors would have perhaps challenged his base philosophy and his base theology. So, science at the core, at its root, is nothing but measuring, doing experiments, and observing. Okay? And there's the scientific method where you form a hypothesis, you test the hypothesis, etc., etc., etc. It becomes a law or a theory, etc., 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 if it passes all of the tests and predictions and so forth. But there is an important aspect within this definition, and this is coming from the Cambridge Dictionary. Okay, and that is this: science is restricting itself to the physical world. Some people would add social aspects in there, and psychology, sociology, and things like that are starting to be wrapped up under what we would call rigorous science. But at the end of the day, science has to do with the natural world and the things that have come from it. Okay? The things that have sprung up from nature. And if you consider humans as having sprung up from nature, then psychology and sociology are certainly wrapped up in that to an extent. But for the purposes of the debate that we're going to watch, they're talking specifically about evolution, right? That's the main issue that Kent is going to attack. And so, evolution being a biological theory, biology being one of the life sciences, but it's still one of the core, what we would consider the core three sciences, right? Physics, chemistry, biology, and pretty much all other sciences come out in some way, shape, or form from one of those or a combination of those. So in that sense, I'm going to restrict my comments to science that has to do with the natural world, or the physical world. Okay, and so when we talk about predictions and how theories are made in the hard sciences or the physical sciences, and hard not meaning physics is harder than biology to learn, hard meaning I take physical data and I don't necessarily rely on statistical surveys of people the way psychology does. And that's not to denigrate psychology in any way, shape, or form. That's how psychologists make progress. But there's a difference qualitatively between the data that we obtain, physics, astronomy, chemistry, and so forth, as opposed to psychology, psychiatry, sociology, and so forth. So when we talk about things, we're going to talk about the natural world. Right now, my background, I'm an astronomer. I teach at the college level, and I've done so for the past, if you include my time as a teaching graduate student, as well as being a professor myself. It's over a decade. Now, that's not terribly long, but it's long enough to be able to speak on the issue from a place of, I would argue, some learning and some understanding. But that brings up a very interesting point this will be the last point that I make, and that is a lot of what Kent says, and I'll point this out again as we go through. A lot of what Kent says and has to say, he argues from a place of authority. He argues from authority. And this is a fallacious, it's a logical fallacy, if you will. And what the fallacy says is, because source A is an expert, whether source A is a person, a book, a body of people, whatever the case may be, is an expert, then whatever they say must be true. I'm not asking you to believe that what I say is true. There's a difference between arguing from authority and accepting that people who have studied certain things, that their opinion ought to count for more than what a non-expert's opinion should count for. And that's the way that most scientists approach scientific consensus. We don't really like to say that just because the majority of climate scientists agree that global warming is happening, that it's a fact. What we tend to say is that it behooves us to pay attention to those scientists and what they're saying, because their expertise is more than mine, and as a result their opinion should count for more than mine. It doesn't mean that I can't read and that I can't learn on my own, but it means that because of they are where they are and the work that they've done, that their opinion should count more for mine. And that's what scientific expertise is all about. It's about taking what's said with a grain of salt and being willing to do your own research, and but also being willing to count that opinion as potentially better than yours if you're a layperson or a non-expert. So with that being said, let's go ahead and dive in. And here we go.
All right, well, let's define a few positions. I believe very strongly that the Earth is about 6,000 years old. It was created in 6 literal 24-hour days. This position would make a few predictions. The Bible says clearly, in 6 days the Lord made heaven and earth.
All right, so let's first stop right here. He says that this position would make some predictions, and that is what a good scientific idea, whether it's a hypothesis or a theory, does. Right? It makes predictions. Now, this is different from a law. A law is usually a statement that says a phenomenon happens under certain conditions. but it doesn't necessarily have any predictive or explanatory power. And that is why theories are the highest idea in science. Okay. When a scientist uses the word theory, we're talking about an idea or a body of knowledge that is well supported by a variety of experiments, a variety of tests, and has made successful predictions. It doesn't mean that a theory can't be controversial. It doesn't mean that a theory can't be disputed. But it does mean that nothing has come forward that has been able to outright falsify that theory. And when something does, we have to either modify the theory or throw it out. And this does happen quite often. It happens more than some people may think. But a good theory, a good scientific theory, does make predictions. But remember, a good scientific theory makes predictions about the natural or social world, if we're going to include the soft sciences. But again, for this discussion, we'll restrict it to the physical world due to the context of the debate.
And all that in them is, everything created in 6 days. Now, based on that prediction, based on that premise, we can make a few predictions, which is what science is supposed to do. A scientific theory is supposed to allow you to make predictions. I predict, based on the Bible teaching, that the universe will show evidence of order and design.
Okay. So, as a physicist, there's a lot to say about this. There's really two ways to look at this. Either you can accept that design does imply a creator, design implies a designer, or you can say that life is so complex and our universe seems to be so ordered that we wouldn't be able to be here if there weren't that order. And there's a number of fundamental constants in nature, namely the things like the speed of light, Planck's constant, and so forth, that if their values were slightly different relative to each other, life would not be able to be possible, and in some cases, not even things like stars would be possible. Either gravity would not be strong enough to pull clouds of gas in and stars form, or gravity might be too strong and any stars that formed would burn through their fuel very, very quickly, and the only things that would be left over are black holes. And when you only have either no stars because gravity is not strong enough to form them, then you don't get planets. And if you only have black holes, you don't have habitable planets. So if we tweaked those values in some of the fundamental constants, it would surely mean that life as we know it wouldn't exist. But I tend to take the view of design with a grain of salt simply because we don't know what caused the universe to come into existence. So therefore, it's hard to say why design exists. As the comedic sci-fi author Douglas Adams noted, looking around and seeing evidence of design is akin to water being in a puddle and being amazed that it just perfectly fits into that particular basin. Of course, water is going to fit perfectly into a puddle basin. It just so happens to be the one that it finds itself in. And so when we look around for design, you could say, well, the universe has to appear to be designed or else we wouldn't be here to talk about it. But the origin of that design, for the moment, is beyond physical science. We aren't in a technological area to probe this yet, nor could we even conceive of what that kind of test would look like to probe why we have design in the universe. So I would call this metaphysical prediction, not so much a scientific prediction. Now, I also need to preface, it's a good question. Scientists love to talk about this question. It is a phenomenally interesting question, and if we knew what the answer was, then we would definitively prove or disprove that God exists. And that is a very, very interesting question. So I will caveat a lot of my critiques about Kent by saying, as much as some of his statements here are not necessarily scientific, they are interesting and valid questions, but they don't fall strictly within the realm of the natural world that we can test.
All over the place, okay? I predict that we'll find thousands of symbiotic relationships in nature. Animals that require certain plants and plants that require certain animals.
Okay, symbiotic relationships in nature. Now, I'm not a biologist, so I'm not going to wax eloquent about the theory of evolution or common descent or things like that, because I only have a very, very surface knowledge of those subjects. And I don't want to say anything blatantly wrong or ignorant. But I will say here's a fundamental flaw. And this is the type of thing that I was hoping the other three professors opposed or opposing Kent in the debate would have brought up. What do scientists do when you have two competing models that predict the same thing? Because evolutionary theory would predict the exact same thing, okay? And a lot of what he says, the creation model predicts, is predicted from the exact same thing. So I would like to hear somebody like Kent or Ken Ham from Answers in Genesis answer the question: what do you do with two models that make the exact same prediction? And that prediction is verified. How do you choose between your creation model and the evolutionary model, or any other type of model, whether it's quantum mechanics or the Big Bang or general relativity or whatever the case may be? So I would ask that question, and we're going to find a little bit further that there's an even bigger problem with that particular philosophical framework. Now, this is a physical prediction. This is a valid biological prediction, but again, the theory of evolution also makes essentially the same prediction, so it's not really a point in creationism's favor.
And it works just fine because they were all created within a few days of each other. Not a problem at all for the creationist viewpoint. I predict that there will be limits to the variations that life forms are able to produce.
Again, it's a bit of a vague prediction, right? And this is something else. There's a lot of problems with the way Kent proposes his predictions. Number one, a scientific prediction tries to be as precise as possible. So given the knowledge that we have at the current moment, when we make a new hypothesis, we try to couch our predictions in as precise language as possible. So that way, when we run a test, it's very easy to see if the test has been falsified or verified. If I predict, for example, well, I'll use an actual specific example. When we measured the energy of electronic transition between the first and second levels, the first and second energy levels, or the ground state and the first excited state in the hydrogen atom, Niels Bohr was able to derive a model that explained the hydrogen atom extremely well. And he didn't just produce a prediction for a general trend that the energy levels would get, the differences in your energy levels, the ground or first excited state to the ground state, or the fifth state to the fourth state, or the eighth state to the seventh state, and so on. he didn't make a general prediction about what the trend should look like, that the gaps between the energies should get smaller as you go. He made specific predictions about what those energies ought to be. And so this was a very specific prediction / measurement, that if the measurements did not agree with his prediction, we were very easily going to be able to throw out that model and say it's absolutely not correct. So when he says there are limits to variations, I would ask, what are those limits? Give me an upper bound and a lower bound. What types of limits are you talking about? And when you say variations, what do you mean by variation? This is a very vague prediction, but the evolutionary theory predicts the exact same thing. For the life on this planet that's based on DNA, we observe a lot of different types of DNA, but there's a lot of similarities, and so you could argue that that's a limit for variation. So again, a very vague prediction, not very scientific. It does have to do with the natural world, but it's not a very specific prediction.
The Bible says they will bring forth after their kind, and that's what we have observed. 6,000 years of...
Okay, I know I'm pausing the video a lot, but I'll make one quick comment here. Biologists don't generally use the word kinds, if I'm not mistaken. If anybody is a biologist and wants to correct me on that, feel free. But what he doesn't do with this slide is define what a kind is. Is a kind a species? A species has a very specific definition, and it fits in a very specific place within the hierarchy of organisms. Kingdoms, phylums, species. I don't remember all of the order. It's been a long time since I've taken biology. But species has a very specific definition. And as you look at this slide, okay, all of these seem to be what we would colloquially call dogs, or canines. But what is a canine kind? If he's going to use the word species, then he should use the word species.
Of human history shows us dogs produce dogs.
Dogs is not a very specific biological term.
Every time. Might be a big dog or a little dog. It might have curly hair or straight hair, but it's going to be a dog, guaranteed. Okay? Farmers actually count on that. I mean, when they plant corn...
Okay, he's going to make a very bizarre statement here, so I'll make my comment.
They expect to get corn, and so far it has happened. So certainly there are very...
So he jumps from using dogs as a kind to using corn as a kind. So again, I don't know what he means by kind. Something else that I would mention is, remember that domesticated dogs came from wolves. We were able to breed wolves to be work dogs, thousands of years ago, and domesticate them and turn them into... We were able to essentially change their breeds. We didn't turn them into a new species. So when he talks about kinds, again, it's just a very vague term, the way he's using it.
Variations, but there are definite limits to the variations, and this is where the major difference comes between the creationist and the evolutionist. I predict that there are not only limits to the variation, I predict that there will be actually a purpose to life, because...
Okay. So I predict that there will be a purpose to life. This is a philosophical / theological prediction. This is in no way, shape, or form scientific. So if I were to grade these predictions on whether they are scientific or not, all right, This particular prediction would get a D, maybe even a D minus, because once again, whatever the source of the order in our universe is, if it weren't ordered in some way, we wouldn't be here to talk about it. So it has to be ordered. This one is a C minus. Biologists might argue with me on that. This one is nearing the F range simply because it's way too vague, and the evolutionary theory predicts the same thing. The only reason this one gives a C minus, I'm giving this one a C minus, is because it actually is a little bit more grounded than this one. But predicting that there's a purpose to life, it's not a scientific prediction. That's not a scientific prediction in any way, shape, or form. Now, does that mean it's a useless statement? No. Philosophers, theologians think long and hard about this question. And scientists like to throw it into our discussions. But at the end of the day, it's not a scientifically investigatable question. I can't design a test to see whether there's purpose to human life or any life on the planet or not, unless you want to argue that our purpose is to eat and procreate, the genetic drive to pass on our genes. You could argue that that is a purpose to life and that that's built into our DNA, but from the philosophical slant of what is the meaning of life, that's not even a scientific question, and that is almost certainly the avenue he is approaching the question from. So this one gets an F.
Because we were designed by a creator for a purpose.
Okay, so we were designed by a creator for a purpose. That's a prediction. No, he just made that as a statement without backing it up in any way, shape, or form.
A prediction based on the Bible view. I predict there will be non-material things like love, sense of justice, mercy, innate knowledge of right and wrong, a conscience, and absolute truth.
Once again, fine philosophical ideas, but whoops, wrong slide. Oh, nope. I forgot to put that one in there. So forgive me. But this particular prediction is not scientific in any way, shape, or form.
Those things are
It gets an F.
not possible with the evolution theory. They are predicted based on the creation theory.
Not possible based on the evolution theory. Once again, a statement with no backing. There's no evidence that he provides that those things couldn't arise by natural means.
Designed this for a reason. I predict that there will be a way to find the will of the creator, such as messengers speaking for him, or maybe even a book.
Completely a theological stance. There's nothing scientific about this. This isn't even a philosophical stance. This is absolutely a theological stance. From a theological perspective, it's a very good question. If we were created by God or gods, what do they want with humans? How would they communicate with us? These are good questions to ask, but have no place in a scientific debate.
Telling us why he did it and how he did it. I predict there will be an afterlife where we will face the creator.
Again, an absolute theological stance that has zero scientific tests that I can design for this. And you can argue, what about the people who've died and come back? But did any of those who have claimed to do that actually face the judgment as accepted by a large fraction of Christendom? And so you could say, okay, a scientific test might be we put people in a coma and artificially kill them and then bring them back and have them describe what they saw. But again, that's not a falsifiable test, given that if God wanted to veil himself from such a test, he could do so. And you could always argue that God simply wanted to hide his nature in such tests if they came back not affirming your view, right? Like if people died who were supposedly Christians, and then you brought them back and you asked them to describe things, and it wasn't what you were thinking it ought to be, you always have the out, well, God was hiding himself. And that's what separates religion from science. And I'm not trying to dog religion. But what I am saying is that you can't have those types of non-falsifiable tests in science. It's just not science. It's a fine religious stance. There's nothing wrong with it from a religious standpoint or a philosophical standpoint, but it just doesn't have the rigor to be a scientific stance. So again, in a scientific debate, bizarre why he's going here.
To give an accounting, okay? The Bible dates, if you add them up in Scripture, comes to about 6,000 years ago for the creation. Not...
This is tricky, okay? Here's where I would really challenge Kent Hovind, Ken Ham, and the other folks who preach and teach 6,000-year-old history as literal interpretations of the Bible. Why? Why does the Bible have to be interpreted that way in those passages? We know a good chunk of the Bible, and even the literal folks, most of them anyway, often will interpret passages in Psalms and in many of the prophets, where the prophets are speaking metaphorically, obviously, as passages of allegory or metaphor or poetry or what have you. So my question would be, what rules are you applying that make you say that the first chapters of Genesis must be interpreted literally? Many religious scholars, if not the majority of religious scholars from the earliest centuries, even before Jesus was alive, when the Hebrews were writing down these books, even before Jesus lived, people were thinking about what it meant for the days of creation. And Jewish scholars, Judeo-Christian scholars, specifically Christian scholars, since have been talking about it, thinking about it, and many of them, if not the majority of them, don't accept that the universe has to be 6,000 years old. And they do it purely on theological grounds, and it doesn't even really have to do with modern science. Some of them are able to modify their opinion because of the science, and they say, well, if science and faith, or reason and faith, have to be in conflict, if the science is sound enough, then it may be that I've misinterpreted my book of truth. And that's okay, but many of them have come to that conclusion based simply on theological grounds alone. And what I find really disingenuous about the creationist movement is some will claim that Hebrew grammar demands this, that it demands a literal 24-hour day interpretation of Genesis 1. But many Jewish scholars and rabbis say that that's not the case, that Hebrew grammar does not demand that, and they don't interpret it that way. So again, I would go back to, just because a Jewish rabbi says, no, Hebrew grammar does not demand that, doesn't mean that he's correct, right? We can't argue from authority, but it does mean that perhaps his opinion should carry more weight than mine. And what I think from just a plain reading text, maybe they've thought about it and have learned more than I have and know more than I do about the Hebrew language, which they assuredly do. And so I just find it bizarre that that many creationists hold to this, that the Bible must be interpreted this way, without much thought to when to apply a literal interpretation versus a non-literal interpretation.
Millions. There's a large difference between 6,000 and 20 billion. Congress doesn't seem to understand that, but there is a big difference, okay?
I agree with him on that.
Now, based on the Bible teaching that the earth was originally created where people lived to be 900 years old, I predict we will find lots of legends about a golden age and a creation event.
Okay, once again, this is more of an anthropological prediction, and you can argue that anthropology falls under science, but this prediction, if it were confirmed, in no way, shape, or form affects the theory of evolution. It stands to very big reason that the same cultures that gave us Zeus and gods standing on a mountain, drinking ambrosia and throwing lightning bolts, would also tell stories about humans that would be fantastic. So that in and of itself is, again, not a scientific prediction, nor does it have any relationship to evolution. Plus, it doesn't tell us anything, right? Again, it seems to reason that most of the ancient cultures would have fantastic stories about gods and humans. So that it's a bizarre statement.
It seems to be kind of universal throughout history. Most people believe there was a creation, and most people believe there was a time when man used to live to be nearly 1,000. The Greeks talked about it, the Babylonians talked about it, the Sumerians. Everybody talked about this golden age. Why? Well, that's predicted based on the creation viewpoint, okay? I predict there will be skeletons found of people showing signs of great age, because they were living to be much older, you know, before things happen. And as you grow, especially the brow ridge of your head never stops growing. The constant pull on the back of your head, the occipital bun, based on just the muscles from holding your head forward, is going to elongate the head over 200 or 300 or 400 years. People would look exactly like the Neanderthals look.
Okay, so he's basically saying that, or he's challenging the notion of the Neanderthal, right? He's challenging the notion that some of these skeletons we're finding that we're attributing to the Neanderthal species are in fact humans, and they're part of the result of these people living these long ages. Now, this debate happened in 2004, so I can almost forgive Kent for not knowing about the advances in the DNA that we have made regarding some of these skeletons that we found, and we have shown that Neanderthal DNA is distinctly different from Homo sapien DNA. But this is where I would challenge him again on the stance of, okay, you have a prediction, and that prediction is essentially the same as the evolutionary theory. We have these skeletons in the fossil record. So if a more specific and confirmed prediction from the evolutionary viewpoint came about, would you be willing to change your mind? Or are you able to somehow modify your prediction to be just as specific? But that would put him in a very difficult bind here, because he's claiming they're human. He's claiming they're human, so their DNA ought to change, or ought to be the same as ours, or he would have to accept that they somehow did change, which is essentially what the theory of evolution teaches. So this particular prediction, especially given the last 15 years of DNA research, would really put him in a bind. we can put an asterisk next to that because the debate happened before. Most of that knowledge was known. But philosophically, anytime you make a prediction as a scientist, you have to be willing to change your mind when new and better evidence falsifies your prediction.
Brain 13% bigger than ours, few strange things about their head, but 100% human in every respect. I predict that there will be biological problems with modern man, such as wisdom teeth, because we're not as big as we used to.
Again, not a specific enough prediction to challenge evolution. Evolution doesn't tell us that over time beings become perfect, right? Organisms become perfect. All it tells us is that certain traits get selected for due to certain pressures, but that doesn't mean that problems don't and won't persist in other ways in other areas. So the issue of teeth that cause problems or are potentially causing problems is not really a challenge to evolutionary theory.
To be. And we're developing probably faster. People are maturing faster. They're only living to be 80 or 90 instead of living to be 900. And wisdom teeth are a problem today, not because of evolution, but because we're actually genetically inferior to the original model, Adam and Eve, okay? I predict that there'll be a universal longing for things to be restored to the Garden of Eden.
Terribly vague. Terribly vague. I don't even know what this prediction means, right? What does longing for the Garden of Eden mean? He doesn't state what that means, and it's just not scientific.
Conditions. That's what everybody seems to want, okay?
So, if I were to rate this particular set of predictions, this one is not enough to say anything. It doesn't really challenge anything. Logically, just based on what we know about our ancestors, it makes sense that, you know, those stories would arise. This one is not specific to the creation model. Evolution predicts more precisely what those skeletons should, what properties those skeletons should possess. This one is not really here or there. Again, it doesn't disprove evolution in any way. Biological pressures and the way that natural selection operates does not get rid of all issues that an organism may have or face. And so that one doesn't really work. And this is so metaphysical / theological that it's so far out of the realm of a scientific inquiry that, to paraphrase a physicist when he was confronted with a really bad paper, and he said, "You're not even wrong." And that's what I would have to rate this one here. He's not even wrong. It's so far out of the ballpark, it's not even conceptually tenable.
Now, what difference does it make if you believe in evolution or creation? Well, if evolution is true, how do we tell right from wrong?
How do we tell right from wrong? The same way that an atheist can become a police officer to protect their community, or the same way that they can become a firefighter to want to save people from burning to death, or the same way that they can become philanthropists and activists in their community to fight homelessness, or feed poor people, or try to give poor people shelter. Some of the biggest philanthropists in the world are atheists, or at least don't ascribe to the Christian religion. And so because he's bringing this in from the creation model, you would not only have to describe why an atheist can be charitable or have a moral compass, but you would have to explain why every other religion also is able to have a moral compass. This is, again, just absolutely not scientific in the physical science sense. So it's just a very, very bizarre statement.
Anytime tonight, I would like any one of these gentlemen to answer the simple question: if evolution is true, how does anybody tell right from wrong? If I wanted you to make a list of 10 things that are
it's an ethical question, right? It's ethics, not science.
Wrong. Before you put anything on the list, I want to know, how are you deciding? Are you deciding right from wrong based on what Osama bin Laden thinks? Do we decide right from wrong based on what Congress thinks? Do we decide right from wrong based on the majority? How do we decide right from wrong? Simple question. I've never had it answered. If evolution is true, death brought man into the world, and death is actually the hero of the plot. Because if evolution is true, one animal evolves a little better than the rest for some reason, maybe a mutation or something. What must happen to the rest of them?
It would absolutely be mutations. That's how things change.
They have to die. Otherwise, the good genes are diluted back into the population and lost. Evolution is a religion of death. Death is actually the hero of the plot.
He will make several references throughout the debate to evolution being a religion. It's not. And the way that I would argue that it isn't, religion is a structured belief system that an individual or a community may possess with a common belief or set of beliefs. That's different from science. And the main difference is when scientists are confronted with data that invalidates a model or a hypothesis or a theory, we're forced to change our minds. So evolution is not a religion. Now, is it possible to ascribe science as a religion? Sure. There are some people who what we would consider worship scientism, or the belief that science is our only access to higher truth. But at its root, that is not what most scientists do, nor practice, nor preach. And so if we delineate science as a body of knowledge that changes as new information is acquired, then it most assuredly is not a religion, because a religion, its fundamental tenets don't change over time unless a broad group of people agree that it should and needs to, and then agree what to change it to. So science is most assuredly not a religion when it's used in that context, and claiming that it is simply a false statement.
If the Bible is true, then man brought death into the world. If evolution is true, death brought man into the world. These two views cannot possibly be more opposite. Somebody is wrong. And I enjoy showing them who they are, and that's why I'm here. Okay, now, the Bible says clearly that by one man sin came into the world, and death by sin. The reason we have death and suffering today is because of man's disobedience to the Creator. The Bible says by man came death. In Adam all die. We have suffering and death because of man's disobedience. If evolution is true, you could read Charles Darwin's book, page 170 or page 217. He said, hey, the death and struggle for life is a wonderful thing. That's how we get ahead. Okay? Now, the creation view says there was a flood about 4,400 years ago. Now,
okay, I'm not going to get into all of the scientific problems with Noah's flood. If you look at the evidence for a global flood geologically, most experts agree it's very scant. It's not there. If you look at the amount of water that the flood had, it would be an astronomical amount. Now, but the reason I'm not going to criticize it or talk about it is because it's always possible that the flood itself was a miracle and the earth recovering from it was a miracle. So there's no way to falsify that hypothesis. But if you want to restrict your attention to physical details about geology, it challenges the notion of a global flood, especially a 40-day rain flood, very severely.
This would make a few predictions. Based on the idea that there was a universal flood, I think I could predict that the Earth will have hundreds of layers of strata.
Okay, so he's predicting that the Earth has hundreds of layers of strata. Geology predicts the exact same thing. Once again, how do you choose between two models that say the same thing? You choose the one that is more specific and or makes better predictions and or passes those predictions.
Floods automatically do that. Moving water sorts particles in all sorts of layers. You can get a jar of dirt, add some water to it, and shake it up and set it down, and in 20 seconds you'll have layers forming in your jar. Moving water automatically sorts particles. It's called hydrologic sorting. You engineers ought to know about that. I predict, based on the Bible teaching of the flood, that there will be billions of fossils, including coal and oil, found in...
Once again, geology predicts the exact same thing.
Those layers of sedimentary rock that we find all over the Earth. I predict that there will be huge canyons and deltas showing evidence of rapid, massive erosion.
Yeah, there are canyons and deltas that do show evidence of rapid erosion. We do know that catastrophic geological changes can happen. But by and large, they're not as common as the canyons and so forth that show the evidence for water cutting through them over really long periods of time. So this one... It's not a very sound scientific prediction.
I predict there will be legends of...
I'll say one more thing about that one. If you really want to be scientific about it, then you should predict or make a statement about the number of or at least ratio. What is the ratio of canyons that you feel ought to possess this feature or features compared to the canyons and delta river beds that don't? That would be a very interesting prediction.
Of this worldwide flood found in cultures all over the world.
This is a sociological / anthropological prediction. It is an interesting thing when you look at ancient cultures, and many of them do talk about floods. But is that evidence for a global flood, or is it possible that there was an era where the climate was slightly different and precipitation was more common, large amounts of precipitation was more common, so different parts of the world experienced more extreme flooding for an era? It's not very specific why... There are competing models, right, that you can build and go back, and we even have the ability to say some things now about older climates, climates that were around roughly 100,000 years ago. So it would be interesting to run some models and see if there were eras where precipitation was larger. and what the implications of that were. And that would also potentially shed light on his third prediction here. So once again, you can say the Bible predicts these things, but due to their lack of accuracy and what you're actually arguing, not evidence for anything.
World. That's a prediction based on the biblical view. Biblical view of creation is certainly scientific. It makes predictions.
He's stated a lot of predictions, but remember, for a prediction to be scientific, it has to be falsifiable. I have to be able to design a test, at least in principle, whether we may not have the technology, but at least in principle, I have to design a test that if the results come back against the idea, that I may be forced to discard the idea at worst, or at best, depending on how you look at it. At best, I have to modify that idea. And I would ask Kent if he came across a test that invalidated any of these predictions, would he be willing to change his mind?
Okay. I predict there will be petrified trees in the vertical position, extending through all of these layers.
If there was an era of flooding, or even just a few major floods over a few thousand years, you would expect to find this.
Thousands and thousands of these trees have been found around the world, petrified, standing up, connecting layers that some people want you to believe are different ages. Now, I don't know how long a dead tree stands up around here before it falls down, but up in Pensacola, you get maybe 5 or 10 years maximum before the tree falls over. And yet they're telling us these layers are different ages. We have dozens of pictures of these polystrate fossils on our website, drdino.com. Now, if somebody wants you to believe the layers are different ages by millions of years, well, they're welcome to teach you whatever they want, but this is simply not in accordance with the evidence. I believe the Bible would predict we would find things like this. Polystrate fossils. A worldwide flood would do that.
A local flood would do that. Or local floods would do that.
Now, science means knowledge, okay? A more expanded definition of science means knowledge gained by observation and study and testing. My contention is there is absolutely nothing scientific about the evolution theory if we define what we mean by evolution carefully, which I want to do in my last few minutes here. I like science. I taught high school science for 15 years. I love the study of science.
I will have some things to say about this, because he's going to cross directly into my area of expertise here in just a moment.
Science. I am not against science, but I'm against using lies to support a theory. And I'm certainly against telling people that science can go farther than it really can, okay? Now, Texas has a law that requires textbooks to be accurate. So does Florida. Florida Statute 1006 says there must be accuracy of instructional materials. Textbooks ought to be accurate. Wisconsin says textbooks ought to be accurate. Alabama says textbooks shall be adequate and current. California says textbooks shall be factually accurate. Minnesota says a teacher shall not deliberately suppress or distort subject matter. These are all wonderful laws, but not one of those states enforces them. The textbook says we have evidence of evolution. Okay, what kind of evidence do they give? This guy says evolution is fact, not theory. Birds arose from non-birds and humans from non-humans. No person...
I will grant him a point here. This is sloppy language. If this particular textbook does in fact say this, I would caution against such language. Evolution is a well-established theory. It is a well-established theory, but at the end of the day, it is still a theory. And we try to shy away from the language of proved. What we can do, though, and what biological or the biological sciences / biologists can try to do is tell us the confidence level that they have in it. So given the breadth and width that they have tested the theory over, and the number of predictions that they've been able to verify, we have very high confidence. Okay, we have very high confidence. I would shy away from the word fact, but we have very high confidence. The reality is, if you talk to anybody who is developing drugs to fight infections, fight against germs, and fight against viruses, the basis for all of those endeavors right now is evolutionary theory. There's no other approach that reputable scientists in those fields are using right now. We don't. Evolution doesn't have a legitimately scientific competitor. We're trying to find one. If you could break the theory of evolution and show that it was flawed and develop a superior model, we would absolutely embrace that. We would love it. And there are people trying to do just that. You would get a Nobel Prize. You would go down in scientific history with Newton and Darwin and Einstein. It would be a major breakthrough, but nobody's found it yet. So it is well established. It's one of the best well established theories in all of science, frankly. I personally would shy away from the word fact, but we'll move on. But I would grant that this is a point, perhaps with an asterisk in Kent's
And who pretends to any understanding of the natural world can deny these facts. Well, it's okay to make a statement like that, but that's just a mantra. That doesn't make it true because he states it. Even if he states it,
most of what he has stated is a mantra. Most of what he has stated, he claims to be true, but has given no reason other than the Bible says so for it to be that way. But again, as I stated before, many people, even within Christendom, disagree with him. So what is his basis for his statements?
it loudly and forcefully, it doesn't make it true, okay? The word evolution has 6 different meanings. First of all, there would have to be cosmic evolution. That would be the origin of time, space, matter. They try to answer that with the Big Bang Theory, with which there are numerous problems. We cover that on our videotape number 1. The second meaning or level or stage of the evolution theory would have to be chemical evolution. If the Big Bang produced hydrogen, well then how did we get all these other elements? They want me to believe that uranium evolved from hydrogen? That's, oh yeah.
No physicist or chemist would use the word evolve in this case. I understand where he's trying to go, but this particular line of reasoning that he's going to give is particularly troublesome and intellectually dishonest, and this is where I have the biggest philosophical problem with his approach here. And this is why when others have called him a liar and a charlatan, I tend to agree with them. I try to be respectful of people's views, but once these statements that he's about to make are made, they're so easily refuted that we really don't have a conclusion other than he is purposefully trying to distort what the science is saying, and that really sets up a straw man argument. He's attacking things that aren't what the theories say, and when you do that and attempt to criticize that, that's your straw man. So this is where I would really claim that he actually is a liar, a charlatan, and not intellectually honest. And for somebody claiming to come at this from a biblical, godly perspective, that is unconscionable in my book.
You get fusion in stars. Well, first place, you can't fuse past iron, number 1. And secondly, if you want the stars to produce the elements, you have a chicken and an egg problem here. Which came first, the elements to make the stars or the stars to make the elements?
This isn't a problem. I'll explain here in a moment.
You have a real problem here, but they never talk about chemical evolution. I'd like to hear that answer tonight. Thirdly, we'd have to have stellar evolution. The stars would have to evolve. Nobody's ever proven the formation of any one star.
This was shot in 2004, and by that time, Hubble had ample evidence for this.
We see a few spots getting brighter, and they're assuming a star is forming. No, it could be the dust is clearing. It could be a supernova taking place. There's all kinds of explanations. Nobody's ever proven a star can form. And yet it's known now that there are about 11 trillion stars per person.
This one, he's accurate. This is roughly the scale of the number of stars in the universe.
On this planet. Each of you could own 11 trillion of them. How did the stars evolve?
11 trillion times, 7 billion. That's within an order of magnitude or so of the total number of stars we think are in the universe. Roughly 10 to the 22-ish.
Fourthly, we have to have organic evolution, the origin of life. How did life get started? Fifthly is macroevolution, where an animal changes to a different kind of animal. Nobody's ever seen any of these first five.
That's a very misleading statement.
Is what's called microevolution. I object to the term, but they use it, so I'll use it. Microevolution tells us there are varieties within the same kind.
Why he objects to that term, he doesn't say. So, why? And especially since this is the one that he concedes we have observed, what's the problem with the verbiage?
Big dogs, little dogs. Okay. This one happens. The first five are purely religious. And if you want to believe in those first five, you enjoy yourself, but don't.
No, they're not. We'll go for a couple more seconds and then I'll say something else.
Call it science. And don't make me pay to teach that to the next generation of kids as part of science, because it's not. It's nothing but a religion. They teach 20 billion years ago, Big Bang, and that's what the evolution.
Okay, I'm struggling to understand where he gets this 20 million from. Even by 2004, we had observations from the COBE satellite in the 80s and 90s refined that estimate down to, if I remember correctly, I will double check this and I'll put a note in the comments about it. But I think the COBE satellite had whittled it down to about 15 billion. And the WMAP data from the WMAP satellite narrowed it down to about 13.7 plus or minus 0.02. So now, that number could change. That number was updated by another instrument in 2015, but again, it just seems bizarre that you wouldn't use the most currently accepted answer and the number that had been there for at least a few years at this point. You wouldn't have had to search hard. The internet was well developed by 2004. It was easily searchable information. He obviously pulled this from some textbook, but it certainly wasn't a current one.
Theory is based on, you have to have an origin point. 18 or 20 billion years ago, there was a Big Bang. I think the evolution theory, as is currently taught in our textbooks, is totally unscientific. There is not a shred of evidence to back it up, and I simply resent paying for it. So my position is that the evolution theory, which teaches clearly 20 billion years ago Big Bang, then it says millions of years of torrential rains created the oceans as the earth cooled down, cooled down into a rocky crust, and then oceans formed over millions of years. This textbook...
Okay, we are still working on what the source of water on the planet was after the earth formed. We have some ideas, but we're not 100% sure. So he's claiming a global flood, but complaining about a lot of rain. Okay.
It says, swirling in the waters of the oceans is a bubbling broth of complex chemicals. Progress from a complex chemical soup to a living organism is very slow. Sure is. It don't even happen. That's how slow it is.
Again, a claim with no backing to it. Where is your proof that it doesn't happen?
This guy said the first self-replicating systems must have emerged in this organic soup. So according to the evolution theory, 20 billion years ago, Big Bang, 4.6 billion years ago, the earth cooled down. It rained on the rocks for millions of years and turned them into soup, and the soup came alive 3 billion years ago. So great-great-great-great-great-great-grandpa was soup. Okay? Now, it's true there's a lot of dogs in the world, but they didn't come from a rock.
He's going to make a very weird statement here. So let me back up and give it to him.
Came alive 3 billion years ago. So great-great-great-great-great-great-grandpa was soup. Okay? Now, it's true there's a lot of dogs in the world, but they didn't come from a rock.
There's a lot of dogs in the world, but they didn't come from a rock. This is the perfect example of the straw man that I was commenting on. Evolutionary theory does not predict that life originated from a rock. So when you set up an argument against an idea while simultaneously misrepresenting that idea, he's not even honestly addressing what evolution claims. It's one thing to say, I don't accept the theory of evolution, and here's why, but giving an honest account of what evolution says, and then what your objections to what it says are. Objecting to things that evolution doesn't even claim is like complaining about a crime novel that it wasn't a car manual. Crime novels don't claim to tell you how to fix your car. And complaining that it doesn't because you're broken down on the side of the road and the book you have is a car manual or is a crime novel, and complaining that's exactly what he's doing, without explaining that that's what he's doing. Because again, if he admitted that, then his whole premise would fall apart. But he's just absolutely not intellectually representing evolutionary theory honestly, and that is a major ethical problem for somebody claiming to be a Christian.
3.4 billion years ago, whatever you want to say. So, the evolution is a dying religion surviving only on tax dollars. Evolution theory is positively anti-science. There's not a shred of real evidence to support any of the theories except oft-repeated lies. Let's define one more term in my last 30 seconds. Stupid. Lacking normal intelligence. Foolish. Silly. A stupid idea.
Once again, straw man.
Dull and boring. Evolution is not even a good theory. I think it is stupid. Thank you.
I think it is stupid, therefore it must be stupid. That is one of the most flawed scientific arguments I can think of. But so his initial spiel is done. So I want to come back and I want to again, we can grade this layer of predictions, not to make a bad pun, but I've already mentioned that, you know, these, while seeming to be more scientific than some of the others, like that humanity longs for the Garden of Eden, I don't know how you would test for that, or that we have a sense of right and wrong because we were created. That's not a scientifically investigatable claim. These are more couched in actual science, but again, they're all also predicted by accepted geology. So I don't know what he's trying to argue, right? But here, okay, so cosmic evolution, the origin of space-time matter, and this is the Big Bang, chemical evolution, the origin of higher elements other than hydrogen, and he threw up a periodic table. Stellar and planetary evolution, organic evolution. So he puts on here, and this is why these are straw men. Okay, this is why these are straw men. The Big Bang Theory doesn't address what the origin of space-time and why he would not put them together when addressing the Big Bang is again slightly bizarre. Astronomers and physicists studying cosmology and general relativity have referred to it as space-time ever since Einstein introduced the term 100 years ago. A little bit more than now, a little bit less than when the debate was recorded. So why you wouldn't use the jargon of the field you're trying to critique unless you were trying to be dishonest about your motives. But in any case, the Big Bang doesn't address what the origin of these things are. We don't know. It is a really interesting question, and we would love to find out. But the Big Bang, when it was originated, most notably by a Catholic priest, a Belgian priest / mathematician, he never sought to address that very question. Einstein's equations, he realized, just imply that the universe was expanding, and if the universe was expanding, then at some point in the past it had to be smaller, and you extrapolate that back to a point, and you say, okay, then the universe had to start from a point. But it doesn't argue what started the universe. It doesn't argue where the energy came from. And so, again, arguing that the Big Bang has to be false because it doesn't tell us where space-time came from, where matter came from, where energy came from, etc., 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 is again akin to complaining that your crime novel is not a car manual. The Big Bang has never claimed to know where those things came from. It never claimed to be able to address those questions. And the same thing with number 4, with the organic evolution, origin of life. The theory of evolution never claimed to know for sure how life started. Both the Big Bang and the theory of evolution are simply descriptions of how the universe in one case and how life on Earth in the other case have changed since starting. We can trace those histories, and we can trace them rather well. There's always a chance that some new novel observation will come along and render our current knowledge obsolete. And in some ways, I hope we do, because it means that there's a new thing that we didn't know about. And that's what science is all about, finding the new thing. Scientists love to live at the frontier of knowledge. And so we would love to find answers to those questions. But for the moment, they're not scientific, because I can't design a test to create life. Now, there's a slight, you might say, with the experiment done back in the, I forget what the name of the experiment was, but where they put some amino acids and so forth. No, they were trying to create amino acids, I think. Where they put the chemicals in the jar, and they struck it with electricity to simulate lightning, and tried to determine if any of the resulting chemicals would be self-replicating. But that is still, even to this day, a fairly controversial experiment, exactly what the results of that experiment were showing. And to my knowledge, we don't have a way to just test life in general. Like, I can't run a test and say, this is how life began. And the Darwin's theory doesn't address that. So it's again complaining about something that the theory doesn't even address. Number 2, chemical evolution. So let's go back and let's see if we can find that periodic table he had up here. Okay. So I know the periodic table may be a little bit blurry, but here you've got hydrogen and you've got helium. And this is actually a very striking confirmation of the Big Bang Theory. The Big Bang Theory made 3 very specific predictions. The first is that the universe ought to be expanding. And that prediction was made, and then it was subsequently observed just a short time later in the mid to late 1920s between the prediction and the observations. And the initial observations were done by Edwin Hubble, and that is why we know him, because Hubble discovered the expansion of the universe. And basically what Hubble found was that there is a very good relationship, linear relationship, as a matter of fact, between how far away a galaxy is from our galaxy and how fast it's moving away from us. And we can make these measurements. They're not easy measurements to make in many cases. But we can do it. And we have found that the faster something is moving away from us, the further away it is. And this is exactly what you would expect in a uniformly expanding universe, where everywhere in the universe is expanding at the same rate. Now, modern evidence suggests that the universe is the expansion is accelerating, getting faster. But it still seems like that getting faster is uniform everywhere. So everywhere is still expanding at the same rate. So basically what that means is, if I have two galaxies that are very close, and then a fourth one that's twice as far as the first one, right? So let's say this is the Milky Way. Let's say this is a close by galaxy and another galaxy that's nearby. And the universe has stretched a given amount. And let's say that the universe has stretched a given amount to the point where my first two galaxies are twice as far away from each other. Well, if these two galaxies are twice as far away from each other, then my second and third galaxies are also twice as far away from each other. And my first galaxy and third galaxy are now 4 times farther away from each other. So the farther you are, the more space is going to expand in a given amount of time. And what that means for us is that we're going to measure further things are moving faster away, because as space-time is stretching, the further away you are, the more that stretching is going to cause you to move faster away from us. So that was a very specific prediction, that the rate at which they're moving away from us should be linearly correlated with how far away they are, and that's exactly what we found. A second prediction was the background cosmic radiation. And this is basically the radiation that was left over from the expansion event. Whether you want to call it a bang. Funnily enough, Calvin and Hobbes is making its way into certain scientific circles with the phrase "the horrendous space kablooey" in favor of the Big Bang, and I kind of like the horrendous space kablooey. But if you have an energetic event like that, the Big Bang seems to imply an explosion, and that kind of model is falling out of favor. We don't like to think of an explosion like a firework exploding and the sparks, flying out in all directions. The universe just came into existence, right? This is what the Big Bang is essentially saying. There wasn't necessarily an explosion the way that we think of a bomb or dynamite or whatever, but the universe came into existence under a very energetic event and started to expand. And if you have that situation, then you should have some leftover energy in the form of electromagnetic radiation from that event. And that's precisely what we find. Everywhere, every direction that we look in the universe, we find a very low intensity microwave radiation. And the properties of the radiation, its at least peak wavelength range. We didn't know exactly what the peak wavelength would be, but we knew it had to be either microwave or radio waves when it was initially predicted. And we also knew that it had to have a specific form. We knew that it had to be of a black body form. And this is actually, before I get into the table of elements, this is worth looking at. So COBE satellite black body curve. We knew that the radiation had to have this shape. Okay, so what this is telling you and showing you. Okay, that's terrible. Let me find a higher resolution one. This one will work, I think. So, hopefully. Yeah. So what a spectrum is when you measure the intensity of a given source of electromagnetic radiation at different frequencies or wavelengths, one or the other. And when you have a perfect emitter, we call that black body radiation. And black body radiation follows a very specific pattern in its spectrum. So here we're plotting wavelength. So we're plotting the intensity against wavelength. And all black body radiation has this same kind of shape. It rises sharply at small wavelengths or high frequencies, and then it has a peak, and then it kind of tails off into the low frequency or long wavelength end. And all black body radiation has this same general shape, right? And so we knew that the black body or that the radiation needed to be black body to fit the Big Bang model. So, and this is what I'm talking about with Kent's predictions. This was a very specific prediction. We knew what range the wavelengths had to be in, and we knew that it had to be black body. If we had found, say, for example, infrared wavelengths for the cosmic background, that would have posed a major challenge. An even bigger challenge would be is if the radiation weren't this exact shape. Okay. And to go along with that, once we kind of started to get a sense of how old we thought the universe was, we could predict what the temperature was. And we were able to, the initial measurements when the black body radiation was initially discovered, it fit fairly closely to that prediction. As we learned a little bit more and we refined our models, the Big Bang then started to predict temperatures around 3 degrees Kelvin. I shouldn't say 3 degrees Kelvin, it's just 3 Kelvin. And the currently, or at least the temperature that was measured by COBE back in the late 80s, early 90s was 2.74, which agreed very well with that 3 Kelvin prediction. The WMAP satellite, which was launched after the COBE satellite was retired, even refined this measurement much further. And not only that, it was able to find the minute temperature variations, where certain spots were slightly hotter and where certain spots were slightly colder. And we can even correlate those with matter distributions that correlate with galaxies and galaxy clusters and things like that. So the background radiation and its ambiguities at the minute level, and when I say minute level, we're talking 1 part in 100,000. So 2.74, this only goes out to 2 decimals. This is essentially 1 part in 100. The temperature variations that WMAP was able to measure go down into the 1 part in 100,000 range. So even when you take these minor adjustments into account, or minor temperature variations into account, it is still black body to a very, very high precision. It just turns out that our instruments were precise enough to measure some of those variations. So though, and so those two predictions, the rate of expansion and the nature of the cosmic background, were two very striking confirmations of the Big Bang Theory. And that brings me to the nuclear nuclear synthesis. The third major prediction of the Big Bang was that the initial state of the universe was so hot that particles didn't form, right? And if particles were able to pop in and out of existence due to the uncertainty principle, they were certainly annihilated very, very quickly, either by an antimatter neighbor or by collisions with radiation, which then were energetic enough to cause them to become radiation themselves, pop back out of existence. So you have this really hot gaseous. I shouldn't even call it gas, because it's not gas, because it's not physical particles yet. But you have this really hot energy density. I'll use the word energy density in this expanding universe. And over time, the temperature, as the universe is expanding, the energy should get lower temperature, just for the same way that heat diffuses. As heat enters a room where it can diffuse in, it will diffuse and get cooler. This is why you don't want to use your oven to try and heat your home, because even though you can heat your oven to 600 or 700 degrees, when you open that oven door and the heat escapes, it diffuses into your room. As things get bigger and your total amount of energy that you have is distributed over a larger volume, your temperature goes down. So eventually the temperature got cool enough that when particles like protons and electrons could form and stay stable, they would do so, and they formed hydrogen and some helium. And we have a prediction for what that ratio should be. And it was roughly 25% to 75%. 25% helium, 75% hydrogen. And trace amounts of things like lithium, beryllium, boron, carbon, and things like that. Okay? So trace amounts of essentially this first row. But effectively 25% hydrogen and 75% hydrogen, 25% helium. And so how do you test that? Well, when you look at the oldest stars that we can find, which according to stellar theory, how stars work, are red stars. If you can find a red dwarf star, then this is a star that burns the longest. Okay, red dwarf stars don't go through their nuclear fuel very fast compared to the other types of stars. And so if you can find a cluster of red dwarf stars, or at least red dwarf stars in a cluster, and you can age that cluster based on where it falls on what we call the HR diagram, you can estimate the age of those stars. And you can then take a spectra of those stars and start to determine their chemical composition. And when you look at the stars that we have found that match what we think are the oldest stars, their chemical composition is pretty much identical to what we believe the first elements ought to have been: hydrogen and helium. So when Ken asked, he said Kent asked, we have a chicken and an egg situation. Which came first, the chemicals or the stars? We knew the answer to this well before this debate took place. And so again, this is an intellectually dishonest statement. All you have to do is ask an astronomer, where did the chemicals on the periodic table come from? And they would tell you the Big Bang produced the first hydrogen and helium. It produced the material for the first hydrogen and helium. And about after 300,000 years is the point at which particles became stable. And we actually had atoms forming. But it was that gas that was starting to form as the universe cooled that produced large amounts of hydrogen and helium. Some of that matter. Now here's a big problem. We still don't know how this happened. We don't know what caused the initial clumpings, because if your universe is expanding uniformly and your matter is being produced uniformly, where did the clumps come from to start your first galaxies and star formations? We still don't know the answer to that question, or if we've discovered it, then it's been since I've looked into that. So if anybody has any more recent relevant information on that, feel free to drop it in the comments. But essentially, we knew or know that the Big Bang was capable of producing hydrogen and helium. So as long as you have a mechanism to allow clumps of matter to form or gather gravitationally, and clump, then star formation is not a problem at all. It's absolutely not a problem, and at least not a problem in the sense that he was addressing, because he was complaining about whether the elements were formed first or whether the stars were formed first. And I'll throw a historical tidbit in here. We know that stars are made out of hydrogen and helium in large part thanks to a name you may not have ever heard of, but her name was Cecilia Payne, and she was the first woman to get her PhD in astronomy from Harvard. And back in, I believe she completed her dissertation in 1920, I believe. And many people in the field still refer to that dissertation as the most important dissertation that has ever been written in the field of astronomy and astrophysics. Her insight allowed us to predict what stars were made out of, and then finding with spectroscopy that the signatures matched what we found in the lab for hydrogen and helium. Basically blew the entire field wide open. That allowed us to talk about the energy content of stars, the life cycle of stars, the intensity of stars, the temperatures of stars. All of these things were unlocked with her insight. And so it's very simple to say, okay, universe created the expansion of the universe created the hydrogen and the helium, and that initial gas is responsible for our first generation stars. And as stars evolve, it depends on what type of star they are as to how their life cycle will go. And so if you are a red dwarf star, essentially what you're going to do is fuse your hydrogen into helium, but you're not big enough to really do anything else. So a lot of our stars in the universe are going to end up just as giant balls of helium. Okay, they're just going to end up as giant balls of helium. Larger red dwarf stars may start to be able to fuse some of the higher elements and start to move on to the other stages of stellar evolution that larger stars do. But for the most part, if you're a red dwarf star, there's a good chance you're just going to end up fusing your hydrogen into helium, and your core is not going to be big enough to start the fusion process into carbon. But But if you are a star like our sun, okay, our sun is still technically what we call a dwarf star, but it's not a red dwarf star. Um, and our sun will fuse from hydrogen all the way up to iron. And where is iron? Right here. So Kent was correct that you can't fuse past iron. So the way stellar cores work, the temperatures and pressures are hot enough that particles are bouncing around so fast. Sometimes when protons are moving fast enough and they fuse together, there's a couple of different processes that can happen, but the end result is that eventually four protons will join together to form the nucleus of a helium atom. And when that process is happening, when you're fusing hydrogen into helium, this is when the star is in its main life cycle, what we call the main sequence. So when we talk about main sequence stars as astronomers, these are stars that are fusing hydrogen into helium. Once that process is done, if you're large enough, you'll then ignite helium fusion into your higher elements. And then you will burn these higher and higher elements up to the point where you get iron. And then it really depends on how big you are as a star. If you're not big enough, then once you fuse that iron and you stop the fusion process, you lose heat and pressure in the core, and you will puff out your outer layers of gas. This is what we call a nova. And all that will be left is the core of your star and what we call a white dwarf. So if you've ever heard of a white dwarf star is the remnant of a what we would call a medium-sized star, if you want to think of it that way. Right. So if a red dwarf star is very, very small and a blue giant star on the main sequence is very big, then your medium stars are where you get your white dwarfs. The higher elements that he was referencing are when you get into your larger main sequence stars. Now, without going into the nomenclature of how we name stellar classifications, essentially, once you get into the largest classes of your stars on the main sequence, these are really hot. These are really big. They're very massive. Sometimes they can get up to 50 times the mass of the sun, and they're generally exceedingly hot. Okay, the sun's surface temperature is 6,000 Kelvin, 5,700 Kelvin, if we want to be a little bit more precise. And these, your hottest stars can be on the order of 50,000 Kelvin. Okay. And so when you have a star that big, it's 50 times the mass of the sun. It can be 50,000 Kelvin on its surface temperature. The sun's internal temperature is somewhere around 15 million Kelvin. Okay. And so when you're 50,000 Kelvin on your surface, you're going to be, just an astronomically large temperature in your core. So you're going to burn through your fuel very, very quickly. So these massive stars, even though they have a lot of fuel, they burn through it extremely quickly. So the larger you are, the faster you burn. So you get to this helium fusing phase really, really quickly. And then you burn through the rest of your elements up to iron even faster, right? Sometimes these can take as fast as just a couple hundred years to go from some of the mid-burning stages to higher. And once you get up into these stages where you're burning to these elements, it takes days. All right, it takes days for this process to happen. When these large stars fuse up into iron, once that fusion stops, and again, the exact same thing happens, you start to lose temperature and you start to lose pressure, they're still massive enough that their gravity wins. They don't puff off their outer layers due to the lack of pressure and gravity that the medium stars do. Gravity wins. And it sucks these gases down at phenomenally high speeds. And so these gases are going to crash into the core and compress the core. And that's where you get the energy for the fusion of your elements that's higher than iron. So fusing up to iron is exothermic. You get energy out of it. This is why stars shine. You have fusion that's happening, and in the fusion process, some energy is released. That energy is released as electromagnetic radiation that makes its way from the core out to the surface, comes out to us as sunlight. When you have iron and beyond, or beyond iron, I really should say, it takes energy to fuse these elements. And that energy comes from these gases falling in at these phenomenal speeds due to gravity. It compresses the core really hard. And one of two things happens at this point, depending on how big the star was. This process starts for stars that are about 8 times the mass of the sun when they were born. And again, the upper limit is somewhere between 50 and 100 masses of the sun. But for stars that are in that range, from 8 solar masses to 50 and above, one of two fates. You have one of two fates. Either you will compress that core enough that you will fuse at least some of the material into your heavier elements. But you may not be able to compress the core into the regime beyond nuclear material. Nothing that we have or know of that we could access, that we have physical access to, is more dense than nuclear material. Nuclear not molecules, but nuclear particles, protons and neutrons, when they're in the nucleus of an atom, are so tightly bound. It's the most dense thing you can imagine. Okay. If the incoming gas is not able to compress that core beyond that point, then what happens is the gas rebounds then off of that core, and that rebound creates an explosion that we call a supernova. And so the star will explode, and you'll see a beautiful nebula, many years afterward. And that's the gas expanding from the explosion, but you'll be left with a neutron star. Okay, you'll be left with a star that is just nuclear material, and it is as dense as the nucleus of an atom. But some of the outer layers of that core get blown off, and those outer layers are where this compression from the gases falling in happens, and that's where we get our heavier elements. So these heavy elements are then also spewed out into space with the supernova explosion. You're left with a neutron star. If your star is large enough and the core had enough gravity to pull the gases in fast enough, it compresses the core beyond what that nuclear density is, and the object then becomes a black hole. Okay. So those are the two fates of massive stars. And this is not a problem for stellar astronomy or for the Big Bang. So for Kent to kind of go off on a, rambling of, we don't know where stars came from. We don't know how. Yes, we do. And on top of that, cosmic evolution is not a problem. Chemical evolution is not a problem. Stellar and planetary evolution is not a problem either. By this time, 2004, Hubble had taken images of regions where stars were literally forming. And that is what we have here in the Orion Nebula. Okay, the Orion Nebula is a nebula that's the remnant of a supernova. Um, I believe it's either a supernova or nova. I'll have to go back and look. But either way, this has enough gas in it to form new stars. It has plenty of gas. This is what we call a star forming region. And we've known about the Orion Nebula for a long time, ever since the telescope was invented, essentially. And the Hubble was able to zoom in, and we can actually see dusty disks around bright spots. These are classic evidence of what is predicted for when new stars and when new solar systems are being born. As gas from the nebula is collected in a specific region due to gravitational collapse from some mechanism, if another supernova blew its material out and interacted with a gas cloud, that could compress molecules, and that compression can cause there to be enough central gravity for some of the matter to fall in and start to form a central star. But that process would not happen completely spherically symmetrically, and as a result of that, there's going to be some asymmetries, and what you're going to get is rotation from those asymmetries, and that rotation is going to flatten things out into a disk, and that's what we think we're seeing edge on in these pictures. And these are blow-ups of regions in the Orion Nebula. So we have a hypothesis that stars are going to form out of gaseous regions because they're gas, and because they're going to form from non-symmetric cloud collapses, that should set them into rotation, and that rotation should flatten things into disks, and this is what we see. So it's a little forgivable. No, it's not, because we knew this by 2004. So I was about to say it's a little bit forgivable, but no, it's not. Kent, at this point in his talk, is being simply intellectually dishonest. He has not done his research into what the Big Bang actually says. He's misrepresenting how we understand the evolution of the universe. He's misrepresenting biological evolution. He's defining his terms or he's using terms without defining them. And he is making a list of bizarre philosophical and theological predictions that don't have anything to do with science. So, as a whole, what grade would I give Kent? I mean, obviously an F. Okay. Now, in closing, I'm not out here to destroy anybody's religious beliefs. Like I said, I've gone through my own deconstruction. Still, I'm going through it. If I want to be sincere, but that doesn't mean that I don't respect religion, don't respect people's religions. Where I have a problem is when somebody claims to be a Christian and wants to talk about truth, and yet is blatantly misrepresenting and lying about the things that they're supposedly trying to critique, trying to disprove, trying to undo. And that is such an intellectually dishonest pursuit that I don't even have words with which to put that in. So, in summary, what I would say is that when you talk about science, be sure that you are referring to science the way scientists refer to it. And I'm not making that statement in an effort to sound elitist. I'm making that statement in an effort to sound informed and non-trivial. And the same way that I wouldn't want to walk into a car shop and tell the mechanics how to fix my car if I don't have any expertise in fixing cars. That's just a hubris of arrogance. And that is, number one, a hubris that scientists shouldn't have. Now, that doesn't mean that there aren't some arrogant scientists. Of course, there are. We're human. But it certainly isn't the ethic that a Christian trying to promote a biblical worldview ought to possess. And that is something that I would heavily critique, especially given that they're trying to present what they're saying as truth. Right. If you have lasted this long, I applaud you. If you have any comments, let me know. Let me know what you think. And there will probably be a few more videos to come. Hopefully not this long. But this was just a brain dump for me. Don't even feel obligated to watch this. I hope you do, and if you do, I hope you find it enlightening. But this was more or less a brain dump for me to get some things that I had been thinking about on off my mind onto savable content, and able for me to then move on to the next thing and get my brain a break from this. But that also means that there'll probably be more of these to come. So anyway, if you enjoyed this video, give me a thumbs up. If you didn't like it, then give me a thumbs down and tell me why. But don't, here's a challenge. If you give me a thumbs down, tell me why you gave me a thumbs down. Don't just tell me my video is bad. Tell me why my video is bad. Okay? All right. We'll see you guys.